So hopefully it'll record both audios. And still be able to hear me. Yep, good. Hunter is here. Awesome. All right. It is about that time. So, all right, guys. So has everybody been working on the review sheet? Hopefully most of y'all have. Yes? No? Okay. Can everybody hear me? Yes. I think so. I just can't hear them. Okay. Hold on. Oh. Okay. I think y'all can hear me because I couldn't hear y'all for a second, but I think y'all can hear me now and I can hear you. Okay, sweet. Awesome. I can hear y'all now too. I had to switch the headset over. Awesome. Okay, guys, so I know that we've had ups and downs, back and forth craziness over the last few weeks, and hopefully they'll get everything squared away and settled down so that we can be back in person shortly. So what I want to do today, at least, because I don't think we'll get through everything today with the 25-minute time period that we are allotted for this hour, because we're going till 8:55. So we'll get done as much as we can today, and then we will continue working on this tomorrow. So when we look at this first one here, are there any questions on these first few problems, 1 through 6, determining whether we have direct, inverse, or neither? Direct variation came in the form of y is equal to a times x. Inverse came in the form of y is equal to a divided by x, because this is directed inverse variation. That's just what we have, and that's the main way they are set up. Now, we also had it in the form of y over x is equal to a, where I can divide both sides by x, and we get this here. And it's really helpful because we have the constant term by itself. And that's kind of the main reason we would have it set up in this form here. Now, for inverse, we can do the same thing, get a by itself, but this time we would multiply instead of divide. So we get it in this form here. So we have y over x is equal to a, and x times y is equal to a for inverse. And so when we look at these equations, if we have it in one of these four, either direct or inverse two forms, then we would be able to tell. So when we look at the first one here, 8 times y is equal to x. Well, this one here doesn't quite match up to every single one, but it does match up to this one here, direct variation, y equals a times x. Now, just because it doesn't have the number a times the x, it still works out the exact same, because I could divide both sides by 8 and really get y is equal to 1/8 x. So this here would be our direct variation. Because again, at the core of direct variation, each variable is varied directly. One increases, the other increases. As one decreases, the other decreases by this constant term a, and it could be x or y. We just really have it flipped. So that would be direct variation. Now, number 2, y times x is equal to 1/5, or really x times y is equal to 1/5. Well, that's our inverse variation. X times y equals a. So this here is inverse. This one's a little bit easier to see because it's already set up in that form. X times y equals a number. Now, the easiest one out of the group is, well, number 3. Because we have addition in here, this is neither. So if we have addition, subtraction, anything that's not really multiplication or division, it's not going to be inverse or direct variation. It's not going to be either one of those two. So number 6 is going to be the same thing. It's going to be neither as well, because we have this addition of y plus 1. So it's not going to be direct or inverse variation. So we have that there. So any other questions on 1 through 6? Okay. Because yeah, I think most of y'all enjoyed or kind of liked these out of the whole, because figuring out direct and inverse variation was not that bad. And even with these here for 7, 8, and 9, finding direct and inverse variation isn't as bad as some of the other stuff that we cover. Now, when we look at these here, we're really going back to the x times y is equal to a, and y divided by x is equal to a. Inverse, direct. So this one here, I would be at least making sure that you have it down that inverse is when we do the multiplication, x times y is equal to a, and direct is y divided by x is equal to a. Now, could you do x divided by y for direct? Yes, it works out the same because we will get the same number. It's just those relationships accordingly. Because we can flip these, it just works out that if y divided by x, if it is direct, we get 2 for that number value of a. Well, if we flip it, we would just get 1/2. It would just give us a different value, but it would still work out to be the same. So when we look at any of these here, any of these sets of numbers, we just need to pick which one we want to try. So we'll do 8 and 9, just so we can have these formulas here. So when I look at number 8, what we can do is I can start off by just saying 7 times 14. I'm just picking one. I just picked inverse. It doesn't matter which one we do first. I just picked one. So we do 7 times 14. That would give us 98. So 7 times 4 is 28. 8 carry the 2. 7 times 1 is 7, plus 2 is 9. So that gives us 98. 22 times 11 is going to be 242. Well, since these don't give us the same value, it's not going to be inverse, because again, when we're plugging these in, we're wanting to get the same value. We're wanting to get this constant term a, because again, x and y vary directly or inversely with a constant amount. So inversely doesn't work. So I can go on to direct. So we can do 14 divided by 7, which is 2. 22 divided by 11 is 2. 28 divided by 14 is 2. 34 divided by 17 is 2. 42 divided by 21 is 2. And last but not least, 50 divided by 25 is still 2. So this here, because we got the same value out of each and every single one when we divided y by x, y by its x value, we got 2 every single time. It means that this here is direct. This is a direct variation. And that's all we have to do for this here. We just need to see, is it direct or inverse? Is there a constant amount when we divide the two or multiply the two? Now, as I said, it doesn't matter if we do x divided by y or y divided by x, because if I flipped it, 7 divided by 14, well, this would be 1/2. 11 divided by 22 is 1/2. So if I had it going the other way, we would get a half each time. So we'd still get the same answer, that it's direct. It just gives us a different value for A. Okay. Now let's look at number 9. Now if we look at number 9, we can go direct or inverse. It doesn't matter which. So I'm going to just try inverse. Let's multiply them. So I can do 2 times 29. 2 times 29 will give us 58. 4 times 14.5. 14.5 times 4 will give us 58. 8 times 7.25 will give us 58. 16 times 3.625. Well, that gives us 58. Now, at this next one, if you typed in 24 times 2.416, 24 times 2.416, it gave you 57.984. But when we're looking at this here, there is a little bar above the 6, which really means that this 6 is being repeated. And so if I typed it in a little bit more specific, if you type in a whole bunch of 6s, it'll tell you that this here is 58. And it works out that this is inverse. And this last one here does work out. It's just really close. I had to approximate it out. So it is inverse. It's just that that one there, I couldn't be exact enough to get us the exact answer. But these here are an inverse variation. They vary inversely to each other. And that's all we have to do on these here. And I think y'all feel pretty comfortable with this here so far. Okay. Now this here, I think, is where some of y'all started having some trouble or issues with these type of problems. Now, when we first look at these here, what we really need to be focusing on is factoring. When we talk about just simplifying, we need to talk about factoring. So when I look at the first one here, we'll just look at number 10. 2x squared divided by 3x squared minus 4x. And what we want to do is we want to simplify it if possible, if there's anything that will be simplifiable. Now when I look at the numerator, 2x squared, well, 2x squared is by itself. There's nothing being added or subtracted from it. So, well, 2x squared is as simplified as it gets. There's nothing I can factor out of any of those terms because it's just 2x squared. Now, when I look at the denominator, 3x squared minus 4x, we need to see, is there a factor or that we can factor out? Now, I'm not going to say parentheses, like setting up 2 sets of parentheses and factoring it that way, because we only have 2 terms. and one of them is not a constant term, a number by itself. Because when I do look at this here, 3x squared minus 4x, there is a greatest common factor of x, because they both have an x term in it, so I can factor it out. And x is going to be the only term I can factor out, because between x squared and x, 3x squared and 4x, the biggest value of x I can factor out is going to be just 1x. So let's look at any of the other terms. Well, 3 and 4 do not have any greatest common factors, so it just works out that x is the greatest common factor we can factor out. And I would really, when we do these here, I would really look at greatest common factors first, see if there is a greatest common factor that we can factor out first, because it's going to make it a little bit easier to work with if we start with greatest common factors. Now, when we factor that out, what we're left with is 3x minus 4. When we factor 1x out of both terms, we're left with 3x minus 4. So at this point here, we can factor out, or we can cancel out one of the x's, because we notice here I have an x and x on top and bottom, and we can do this because of multiplication. Since everything is really being multiplied together, we can simplify this here. And when we simplify that, well, one of these here will simplify out with one of these here, leaving us with 2x over 3x minus 4. And in the denominator, the only thing that simplified out was x. So if we're talking about our restrictions, x cannot be 0. That's really going to be the only restriction that we have, because that's the only thing that's simplified out completely. So that one there wasn't too bad of a problem to work with. So we can go on and look at the next one, because that one's going to be a little bit more in depth. There's a little bit more that we need to do with it. So let's look at it. 32x to the fourth minus 50. Now again, when I talked about, or we looked at these here, one of the big things that we'll need is, okay, so we'll look at this here. We won't have one as difficult as this on the test. And when I say difficult, I mean the denominator. We won't have a factoring by grouping on the test. But I'm going to go on and look at it anyways. Now, when we look at the numerator, 32x to the fourth minus 50, there is a greatest common factor between those two terms. And I know for sure that we have 2. But there might be one bigger, and if there is, we can look at it here in a minute. But I want to at least factor out 2. Now, there's not a variable in common with both 32x to the fourth and 50 here. So we'll factor out 2 at least. When I factor 2 out of 32x to the fourth, well, 32 divided by 2 would be 16x to the fourth. Minus, well, 50 divided by 2 is 25. Now, when we look at that, so that's what we have there. Now, the denominator is going to be a little bit more tricky, because we're going to be factoring by grouping. So I'm going to group them together, 4x cubed minus 12x squared. And when I look at 4x cubed minus 12x squared, I know that 4 and 12 do have a greatest common factor of 4. X cubed and x squared have a greatest common factor of x squared. And we're going to factor it out of that 2 there. Any questions on any of this here so far? I don't think so. Okay. Actually, I'm realizing that this here, I don't have any problem doing it. And if y'all have more questions on it, I will do this one later, because this isn't going to show up at all on the test, because I didn't realize that we do have an x to the fourth on top, and it will factor the same as a difference of perfect squares to 4x squared minus 5 times 4x squared plus 5. but we don't have anything of this complexity or difficulty on the test. So I want to move on to 13 because time is limited with these virtual days. So I want to look at something that we will actually see on the test, not something that we won't. Because we won't see a cubic on the test either. I decided to be nice and not include factoring by grouping are essentially a difference of perfect squares with powers of 4 or these cubics. But we will look at 13. So we look at 13, x squared minus 4x minus 12 and x squared minus 4. So we'll look at this one here, and I know I jumped there. But we'll look at this one here because this one here will be a type that you will see on the test. You will see something of degree 2, these quadratics. Now, when we look at the denominator, our x squared minus 4, we are going to need to factor the denominator, this x squared minus 4, which is going to be a little bit easier to factor because it's a difference of perfect squares. Because we know we'll have opposite signs, x and x, 2 and 2. Because x squared minus 4 is going to be x minus 2 and x plus 2. Okay, so we have that there. That wasn't too bad. And again, when we're simplifying these here, these individual terms, I would start with whichever one is going to be a little bit easier to simplify. Because when we look at the numerator, x squared minus 4x minus 12, well, the one thing we do know is because of the minus 12, we know that the signs are going to be opposite. One is going to be positive, one is going to be negative. Now, the factors of x squared are going to be x and x. Now, the only other thing we need to look at is the factors of 12 to plug in here. So our factors of 12 are going to be 1 and 12, 2 and 6, or 3 and 4. Because we're only going to have one of these sets of factors here to work with. Now, when I'm looking at all of these here, 2 and 6 is going to be the one I'm really going to be looking at to use because I really need to have x plus 2 or x minus 2 in the numerator for this to work. And well, it does work out that x plus 2 times x minus 6 are the factors for this here. And now that we have this, because we could go through and check and see if this works by distributing, and we would get x times negative 6 would be negative 6x. Plus 2x, which would give us negative 4x, which is our middle term. So that does work out. So these are the factors. Now, since we have the numerator and denominator factored, well, we see that they have an x plus 2 in common on top and bottom. Those cancel out, leaving us with x minus 6 over x minus 2. And the reason I know I'm done is because there wasn't anything left in common on top and bottom to simplify out besides the x plus 2 and the x plus 2. Now, since x plus 2 and x plus 2 canceled, that would give us a restriction of negative 2. Because since it eliminated out, we need to list it as a restriction. So are there any questions on this here? Okay. So if there are no questions on that there, let's go on and look at least one more since we still have time here. Now we can look at number 14, and I think number 14 has been challenging for some and for some of y'all and not as much as others, and it's kind of a little back and forth. Now there's two main ways we can do this. Now the first main way that we can do this is because since it's multiplication, we can multiply the numerators and denominators out fully and then simplify from there. So when we look at the numerator, the top of this here, well, we have 4 as the only number. So if I'm just multiplying them all together, I just rewrite 4. We have x by itself, so there's only one x. Now the only other thing we do have in common is y to the third times y. And y to the third times y would be y to the fourth. When the bases are the same, we add the exponents. That takes care of that. Now let's look at the denominator. Well, 8 is the only number, so we'll have 8. Now we do have x squared times x, and x squared times x will be x to the third, and then we just have y. So I went on and just multiplied the numerators together, the denominators together, and got this here. Now at this point here, we can simplify anything that's like terms. Well, we can simplify 4 divided by 8, and 4 divided by 8 will give us 1/2. So I haven't written the 1 up on the numerator yet. I'll go on and do that. We don't have to write it as long as there's nothing, as long as there's other terms on top. So that takes care of that. Now we have x divided by x to the third. When the bases are the same and we're dividing, we subtract the exponents, and we'll finish up on this here. So here, x to the third divided by x, well, 1 minus 2 is, not 1 minus 2, 1 minus 3 is 2. And since it's bigger on bottom, it stays on bottom. And last but not least, y to the fourth divided by y. So we subtract the exponents. 4 minus 1 is 3. And since it's bigger on top, it stays on top. And we get this here. Now the other way we could have gone about this is just canceling like terms. So when I looked at this here, well, we could see that this y and this y would cancel. This x and this x would cancel. And 4 divided by 8 would be 1 and 2. The only thing left on top is y to the third. The only thing left on bottom is 2x squared. So that's another way we can do it, and we can do it in either one of these two forms here. All right, guys, so that's it for today because we've run out of time. So we'll pick this up tomorrow. We'll keep working on this here tomorrow. So we'll do another Zoom or Google Meet tomorrow going over the review sheet. And again, so all of you that were here for this year got your attendance for today. And we'll be doing the same thing tomorrow. So y'all have a good one, and y'all can go on and sign out. Bye.